We are going to be going over design patterns today, specifically model view controllers. Who all here is familiar with MVC? One, two, three, four-ish. Here's you? Perfect. Don't worry, we'll go over everything. So before we start, we'll have time at the end to go over some homework questions. I don't know if any of you guys had any homework questions, but we'll leave some time at the end for those. And one of our mentors were concerned with uploading to Canvas, so I just want to ask everyone here: did you have any trouble with uploading to Canvas for your homework or anything like that? All smooth? Perfect. All right, so like I said, today we're going to go over MVC and design patterns, and it's going to be really quick slides. I really hate going over slides, so we're going to jump straight into the examples. Our first example is going to be refactoring a huge, ugly calculator app that I wrote yesterday night. So everything will be in one view controller, and we'll apply MVC to it and refactor it, and you guys will get your hands dirty with doing that. So next one will be creating a really awesome flashcard app with puppies. And yeah, let's get started. So what is a model view controller? So model view controller is just a design pattern, and design patterns, it basically just cleanly separates your code based on role. So it makes it a lot easier to read, and it keeps it a lot more organized when you're building your projects. And it's basically just a kind of standard to keep everything consistent. So when someone comes into your code base, everything's using a certain design pattern, so they know where exactly to look for certain things. So what is a model? The model basically shows you the what of your application. So what does your application store and what does it do? So it also contains where your data is. So if you take like a calculator application, the model would contain all the logic that you use for performing calculations and storing the result. All of that would live in the model. Next, we have the view. So the view is basically whatever you see on the screen when you load up your application to your phone. So that includes like the labels, the buttons, everything that you can see. And it's supposed to be super simple. In the calculator app, it would basically just be all of your buttons and all of your labels. And then we have the last thing, which is your controller, which ties everything together. So the controller interprets and formats information from the model for the view and vice versa. So whenever you make a change in the view, it would go to the controller, and then the controller would delegate to the model. The model would do its calculations and then bring it back to the controller, and the controller would update the view. And then vice versa, if something changed in the model, it would go through the controller, and then it would go to the view after that. So example in a calculator app. Well, I guess I just went through the example. So response, view, update. So MVC, this is basically what it looks like. I made that myself. Just kidding. Hold on. Something like that. You have your model, and basically the changes that happen in the view, it delegates back to the controller any kinds of actions, and you have outlets in the view too. So an outlet is basically just your labels, buttons, everything that you see on the screen. And when you perform certain actions, the view will delegate back to the controller, which would then call the model that would make changes, tell the controller those changes, and then update the view accordingly through those outlets. So another thing here, we're probably not going to go over it tonight, but you have notifications. So how do you have the model transmit back to the controller? You have notifications, and basically the controller will be listening to those notifications, and when the model broadcasts it, it'll notify the controller, and the controller will do its diligence in updating its views. How do you present it? All right, quick slideshow. So let's jump into code. So this is the calculator app that I was building last night. You can see that it's extremely ugly, and this is going to be more of an interactive demo. So what is one of the first things that you guys see that can be refactored with this? Oops. You'll notice that this is kind of ugly, right? You have an outlet for every single one of your numerals. Actually, before I go into this, I'll show you guys what it looks like. just so you believe that it actually runs. So just your basic calculator, plus 8 times 8 equals 64, 6 plus 4 equals 10. So everything works. Now, one of the things that we can do is we can probably extract this out into one outlet, right? So you can actually connect multiple buttons to a single function. So let's say instead of this, we have numeral pressed. And we can actually get that value by doing sender dot value. For my example. Sorry, one more. Results. Numeral plus. So on your outlets, you have the title label on the button. So it'll be sender.title label text, and you have to make sure to unwrap that text, and then you can assign that value to append result. So let me go over what append result is real quick. This is a function that we have in here, and it basically appends everything to the label. So it starts off with 0, and when you hit a numeral, like 5, it'll replace 0 with 5, and then it'll keep appending to that label. So when you hit 6, it'll be 56. When you hit 7, it'll be 567. So that's what this performs. So you have to unwrap it. And if we go back to the storyboard, this is where it gets a little tricky. So you have all these outlets already connected. You have to make sure that you disconnect those first. Otherwise, you'll run your app and it'll just crash on app delegate and you won't know really what happened. So we'll go ahead and do that real quick. Have you guys done anything with outlets yet? Perfect. So what's that? Oh yeah. Perfect. So you guys are outlet experts. That's okay. That's why we're going over them again. All right, so do you guys remember how to hook those outlets up again? Control drag, right? So you can either control drag from the storyboard to your code, or you can drag from here all the way to your outlets. So we'll go ahead and do that real quick. 7, 8, 9, 6, 5, 6, 2, 3. All right, perfect. And we can actually do that for, go ahead and comment these guys out real quick. And we can actually do these for the operators as well. So pretty much the same concepts. Operator pressed. And we would just do perform action instead of append to result. Because whenever you hit divide or multiply or plus, you will make sure to store your first value and allow the user to input a second value. Wait a second. Sorry, this gets a little redundant.
While you're doing that, will you talk about your decision to force unwrap value instead of using
Yeah, sure. So I guess these buttons, you make them in the storyboard, so you always expect them to be there. And I guess me viewing the storyboard here, they'll always have a value because I put a default value in there in the calculator. When you wouldn't want to do that is when you have sort of dynamic buttons. So say like you have certain conditions to make those button texts different. That's where you would maybe use a question mark instead, because in that case you would potentially have nulls in your code. Does that make sense? Alright, so let's go ahead and hook these guys up, and then make sure that everything is still working as we expected. Alright, perfect. So if everything went well, everything should still work, which it doesn't. Fatal error, no. Can anyone explain that? Yeah, do you guys need me to make this bigger at all? Nope. So unexpectedly found nil while unwrapping an optional value. So it's saying self.operator value is probably nil when it got ran. So whenever you hit equals, it would go through these switch and case statements. Are you guys familiar with switch and case statements by chance? Pretty familiar? Okay. So let's see what happens. So it's saying our first value is 5, operator value is nil. So it looks like I forgot to set the value. So let me see. Form action. So should first value is nil. We have to set our operator value, which is real quick. It's not code. So all we have to do is set this equal to our value too, and then it should work. Just breakpoint, and it should fall through, and then we get our result. So we can get rid of all of this code that we have, and it cleans up quite a bit. All right. So based on our model view controller slides, I know we went through that pretty quick, but what do you think our next step should be? It seems like we have a lot of logic in our view controller, like the perform action. So this function right here is actually what gets done when you hit equals. So this will perform the divisor, multiplication, subtraction, or addition. So maybe something we could do is put that into a model class. Does that make sense? And you guys are all familiar with making new files in Xcode, correct? Maybe not? All right, so go back. All I usually do to make new files is right-click inside your directory, and then you go to New File. And depending on what you're making, you'll select either any of these, I guess. So the most common ones that I use is either a Cocoa Touch class or just a regular Swift file. So when you're making models, you're usually going to be using just Swift files that import foundation and everything. But if you're making like classes for view controllers, views, and table view controllers, all of those things would be a Cocoa Touch class. And I'll demonstrate. So this gives you subclasses, and what these basically do is that they fill in things for you, which is kind of nice when you're building a UI view controller. It gives you a lot of structural things that you don't need to remember how to do. But we'll be making a model class, so calculator model. So this is going to be primarily empty. It's just going to import foundation for you, and you have to do pretty much everything else. So we'll just do calculator model. And then we can start the process of moving some of this logic over. So which functions do you think here would be good to move into our model class? We have append to result, which basically controls what the label, basically the result of the label. And you also have perform action, which performs the calculations that you have. That one. Good choice. All right. We'll go ahead and comment this out. Anything else that you see here? So we have the view did load. Is everyone familiar with the lifecycle methods like view did load and things like that? Probably not. So view did load basically gets called whenever you start up a view. So whenever you create this view controller, what gets called the very first time is this view did load. And this is where you do a lot of your initialization steps. We won't be going too big into did receive memory warning because we won't be writing anything too big to where this will probably trigger. So you usually can just get rid of that. Alright, so what's else? So it's complaining now that we don't have perform action in our view controller, but that's a good thing because we'll be importing the model. So maybe this one? I'll help you guys out a little bit. Alright, so last thing might be clear. Clear might be good to have inside our model instead of the view controller because that will actually allow us to clear our results. Alright, so one of the member variables that we'll probably have to keep track of is a results. And let's see if we have anything else. Well, I guess we have to pretty much bring all of these in because these won't live in our controller anymore because we probably want these to be in our view or in our model. Should go in second value. Alright, cool. Hey, look, no red. Just kidding. Alright, so we have to go through and start fixing these. So we won't actually be modifying the view at all in our model. Your model should never directly modify anything in your view. It'll always go through your controller. So what we'll do here instead is we'll return the results. Return results. And it should error here. Can anyone tell me why? Unexpected non-void return. Yep, exactly. So you have to, whenever you're writing your functions, you have to specify what the return type is. So here we're just returning a string, so you just specify it with the arrow. And should get rid of it. There you go. Good job. Alright, so perform action. So that means this will no longer be setting the view, so that should go away. And here, you can comment all of these guys out because we will no longer be modifying those. So here, we'll just return those values instead. So return. Also, feel free to stop me at any time if you have any questions. And we'll actually move this clear, self.clear to the controller because you can't put anything after return statement, correct? So non-void, we have to do the same thing. We'll specify that we'll be returning a string here. And then here, we'll just return that. And it does need a final return, just in case it doesn't get to any of those. There we go. Alright, so we should have our perform action now. We have to return result here. That should be good. Yeah, so self, it depends on which controller you're in, but self in this case would refer to the member variables of this class. So execute, I guess Swift 4 doesn't really enforce it, so you could potentially just do this, and it would refer to the same thing, but I guess in terms of, to distinguish it a little bit better, you just refer to self. So this would be referring to that calculator model's results. Does that make sense? Maybe? Ish? So, like, say you were to make a variable called result here, you could potentially do something like self.result equal to results. And this would refer to the local variable, and this would refer to the member variable of that class. There's going to that because it doesn't have a value, but cool. Right. So now, can anyone tell me what we have to do in our controller? So we'll still keep the controller, we'll just start ripping things out of it and moving it to other classes to organize it a little better. Oops. Yes, we do, but there's one step. So we have our model class right now, but there's no way for that model to really get anything from the controller, right? So we probably have to bring it in to our controller. So you can do that just by specifying our calculator model, and you can actually instantiate it here. And then we can start filling in these functions with our calculator model. So calculator model dot perform action, operator value, clear, clear. And then these would go away because they would be instantiated in our model instead, so those wouldn't be necessary anymore. And now we have our view properties. So if we run right now, it's probably not going to work. Everything so far makes sense, why we moved those functions out to the model class and everything. Alright, so it'll crash because we need one thing in our model. Can anyone tell me what it is? Amanda? Sorry to put you on the spot. We need an init function. And this basically means it was crashing because we had these values, but we never set them to anything. So we usually do that in the init function. So here we could potentially just call this self.clear because that's really what initializes our functions. And we could probably name this a little better. Maybe name it initialize model. Then call that here. That should work. Maybe not. Oh, yeah, sure. Do you guys know what this complaint is, this warning? So whenever you call something with a return type and you don't set it to anything, it complains at you that the return type for that function call isn't being used, which says right there. All right, so none of our buttons seem to be working anymore. What's that?
Have something to do with those warnings.
Probably. Good catch. Very good catch. So let's see. initialize model, self.result.label text. So we have this result label, but we're never doing anything with it. So one thing we could do for now, since we don't have the view, is to do result label dot, see if I can get autocomplete, dot text equal to the return type of whatever this comes back with. So we have that for numeral pressed, and we'll also have this for calculator performed action. Go ahead and change that here. Good. Equal to, and then remember how we removed the dot clears from the model earlier? We do have to put those back in. So every single time you press an operator button, so plus or minus, you have to make sure to clear that label, otherwise it'll still remain with that value. So we'll just go ahead and do that. Oops. Oh, I haven't remembered to use lowercase. Guess I got rid of that. I'll close back real quick. There you go, you have your numbers. There you go, same error. What happened? We never set our operator value again. Whenever, let's see. Have you guys gone through like debugging at all? Or have you debugged on your own with the last homework assignment? Yeah? Setting breakpoints and everything? Perfect. Let's go ahead and do that. Here we go. Alright, so breakpoints, those word errors, our operator value is nil again. So let's see where we're supposed to be setting that, which is in our controller whenever we click an operator button. So calculator model dot operator value equals value. Let's just make sure that still works. So value is x. Then when we hit equals, you can see our calculator model operator value is null. So what's wrong? Where should we set this? Let me refer to what I did last night. So it actually won't be there, but check. Perform action. No. Go back to our view controller. Sorry, this is a live code demo, so there might be some issues right now.
I believe you need to set the operator value of your model and your execution.
Which one? Operator value here. The thing is, you won't have reference to that anymore, so we should be doing that whenever we hit the operator pressed. So,
Well, you're getting the. Okay, so tell me what I'm misunderstanding.
Mhm.
You're getting value from your sender and equals pressed.
Mhm.
So
So here, yeah,
and then if you set calculator model operator value equals value on make a new line after 30,
mhm.
that should set the operator the calculator model operator value to instead of
Yeah. So operator value in this instance, you want to retain it for the operation. So whenever you hit plus minus, you want that to save, and then equal will be your new operator, or your new like operation where you want to total everything. There was that clear that we had. Oops. Um, let's go back to this initialize model. That's sorry, that was a bug. So we were clearing out the model whenever we hit a operator. So it was clearing it out right before we did any calculation. Okay, operator value is minus. Yeah, 53. All right, cool. Crisis averted. Good job, team. That's okay. All right, so now that we have our models, all of our logic extracted out to our models, what do you think is our next step? I think you mentioned it earlier. Yep, so actually adding a view. So right now we have everything split between a view controller and a model. Um, what do you guys think we should extract out into our view? Yep, maybe all of our outlets. So let's go ahead and let's copy paste these guys into our view. Then we'll go ahead and create a new view or a new file. And this will actually be a Cocoa Touch class file. So you can double click on this and it'll just be calculator view. Then if we do that, it should give us more structure, not too much, but it imports UIKit, and we won't be drawing any custom components, so we can actually get rid of that too. So IB action outlets. Now, whenever you're doing this, be a little careful because these outlets, they don't get removed when you just comment them out, potentially. So always go back to your storyboard to check to make sure they're hooked up to the correct things. So now that we created a view too, we'll have to set this view to that class that we just created. So we have to set this to the calculator view, and then now if you weren't setting that, you wouldn't actually be able to drag any of the outlets over to your view class, and it wouldn't actually recognize that it would be using that view. So now we should be able to counterparts manual controller calculator view. Let's kill this window real quick. All right. So let's just make sure. So you notice that it's still hooked up to what it knows as a view controller. So we actually removed it from here. So say we were to drag all of our components to what they should be. So numeral press would be every single numeral. Do this real quick. Operator pressed equals pressed, pressed. Alright, so say you were to run this without checking your outlets and they're still hooked up to that old view controller, even though you commented out the code. Let's actually comment this out real quick. Perfect. So it'll compile and build just fine, but when you pull up the simulator, it has a potential of going to this. So this isn't terribly descriptive, and you won't be able to find where your errors are. So all it says in your error log is that it has an NS exception type. So class is not key value coding compliant for the key result label. So it hit the result label and it just bombed out. So that's because you have your storyboard outlets hooked up to something that doesn't exist anymore. And I know the error doesn't tell you that specifically, but that's what it means. And when you ever see like an app delegate just crash without giving just like an exception error, it's usually a result of some storyboard error. So when that happens, make sure to check all of your outlets and remove references that shouldn't be there. Oops. Should be good. Cool. So now when we start our application, I know it seems like it's really redundant, but those are very important steps, and you'll find yourself spending a lot of time just trying to figure out what's wrong with your application when you have storyboard issues. Mm-hmm. Yeah, sure, absolutely. Oops. Looks like there's something else that's not good. So basically, whenever UI related, like table views, controllers, collection views, or just a regular UI view, that's when you would click the Cocoa file. So anything UI related would go through and um, be under that. So if we actually go through the Cocoa Touch class and we go through all the subclasses, anytime you're making any one of these, I know there's a lot, but you'll probably primarily be dealing with like UI view controllers, UI views, table view cells, and stuff like that. So whenever you have to make something like that, that's when you would select the Cocoa Touch class. And if you select the Swift file on accident, it's not the end of the world. You can always delete the file, or you can just bring in UIKit and then build your class accordingly. But yeah, yeah, it imports UIKit, and also it brings in a lot of structural things. So especially when we start going over table views, it'll bring in a lot of delegate methods that you'll need to implement, which you might not necessarily remember when you're building those things every single time. I know it's really helpful for me whenever I bring that in. So, and in terms of like whenever you need to create a Swift file, that's usually when you need to make some sort of model class or like something that has to deal with backend that has no reference to the UI whatsoever. Hmm? Oh yeah, look at that. Oh, yeah, there you go. Good job. All right, so it doesn't bomb out. This isn't gonna work right now because we don't have anything hooked up, but it renders everything correctly and it doesn't bomb out on us. So let's go back into our newly created view and take a look. Calculator view. All right. So here, this is where it gets a little bit tricky. We're going to go over delegate methods and protocols, and it's something that we'll probably go over and over again because it's sort of an interesting concept, and basically at its core, delegates basically allow you to communicate with other controllers. So you're in this view class right now, and you want to talk back to the controller saying, I press a button. You would implement protocols and delegates to do that. So we'll go ahead and do that now. So for this, um, we'll have to create 4 protocol methods. Has anyone taken like C++ or C at all? Probably not, or you might have. So they're essentially header files. They basically outline all of the functions that you have for this class without any implementation. So we'll create a calculate view delegate paired from class, and this is where we'll define our functions. Request. Is anyone familiar with weak versus strong denotion when you're talking about bars or anything like that? Nope. Who did? Oh, okay. So a weak indicator on this basically, did they go over ARC, automatic reference counting, at all? So it's basically Swiss way of allocating resources to a certain variable. So when you denote something as weak, it doesn't increment that. So the reason you would do that is when you have you get into this condition where you might have 2 strong types that reference each other, and when you have that, both of those resources would never get deallocated, and it's mainly for memory management. So we denote weak here because we don't want to get into a condition like that for classes because classes are reference types. Did we go over structs and classes? Structs versus classes. Okay, perfect. Well, we can go over that now. So classes basically allow you to have inheritance versus structs which don't. So structs are they are value based, which means that whenever you make an assignment to it, it basically creates a completely new struct for that object versus like classes. So classes um, are reference based. So whenever you assign a new variable to a class, it actually doesn't create a completely new class object for it. It creates a pointer to your class. Does that make sense? Have you guys dealt with pointers and references before? Maybe-ish a little bit. So essentially what pointers are is that whenever you create a pointer for a certain object, whenever you reference that new variable that's a pointer to an object, it would reference back to that single object. So think of it as having a lot of different things that reference the same thing, and whenever you modify one of the new variables that you make for that object, it modifies that single object. It's kind of like having a one data store for multiple variables, versus like structs, which does create a new value. So whenever you make a value assignment, it creates a completely new object, and when you make changes to that object, it doesn't modify anything else. Kind of clear? Maybe we'll go over it more later. Sure, I have this right. Oops. Protocol. This we can. It's like you guys see that too, right? The class isn't. It's supposed to be purple, but it builds fine. So it's just a weird Xcode issue. So what this is going to allow us to do is it allows us to call our delegate method here. So numeral press, this will call numeral pressed here, and I think we do need the button value to this. So button value string button value string, and then we'll pass that in to here. So basically what this is, alright, does anyone know what this error is? We'll just go through all the errors just in case you guys have run into any problems when you're making your own projects. So missing argument label button value. Any ideas? Fortunately, this error isn't too big to where you would get stuck because it actually does have a fix for you. So all it is you have to specify the parameter label or the parameter description on it. So we name this button value here. Whenever you pass a parameter in, you have to make sure that you specify button value and then your value. Make sense? Do the same thing here. So perform value equals pressed dot pressed. All right. So whenever you implement this protocol, any class that inherits that protocol, so whenever you inherit calculator view delegate, you have to implement all of these functions because there's no implementation provided for you. So what we're going to do is in our view controller, we'll go ahead and inherit that. So it'll just be calculator view delegate, and it should complain at us about this. So it does not conform. And all you have to do here is, it's really simple. They actually allow you to fill in all the protocol methods that you'll have to implement. So you're going to see this delegate protocol thing pretty much everywhere, especially moving forward whenever you're dealing with table views. Because whenever you inherit from a table view, there's going to be specific methods that you'll have to implement. So that's why selecting the Cocoa Swift class and selecting table view is good because it basically fills in all of those stubs that you need to fill in anyways. So you don't have to go through the process of remembering what you have to fill in or clicking on the error message and stuff like that. So, all right, cool. So I'm actually not going to do this. There's a cleaner way of doing this. Instead of having it be inherited on the UI view controller, we're going to go ahead and actually make an extension method. Have you guys gone over extensions? Man, no, it's okay. I know it's just the first 3 classes. So extension methods basically allow you to, basically what it says, extend certain classes. So think of this as basically just filling in at the bottom of this class. So whenever you do extension view controller and inherit, it'll basically fill in everything for you in this view controller class. So it's all, think of it as one block, but you're separating and organizing it out into separate extensions. So what do we inherit? Calculator view delegate. So again, it'll throw that error saying you have to implement, so we can go ahead and do that. And the reason you sort of want to do this way is because it makes your code a lot easier to read, because all of the delegates that you implement will be in their own extension, and it's mainly for maintainability purposes. It doesn't affect your code at all. Like if you wanted to put it in your view controller as one block, that's perfectly fine. It's just a little harder to read sometimes. So, calculator model. All right, numeral pressed. Let's go back to our view. So whenever a numeral is pressed, it'll be basically what we were doing before, except we'll be interacting with the calculator model. And we'll append results with the button. Same thing here, calculator model dot operator, perform operation, button value, action. This is just going to be the equal operator. Dot. All right, cool. So one thing we are going to have to do. Can anyone tell me what we forgot? Similar to what happened in the model. So we extracted out a model class, and we want to connect it back to the view, or the controller, right? Because the view should never talk to the model. It has to go through the controller. So what we have to do is we should probably bring in our calculator view that we made. So we'll just create it here. View. Oops. And this will basically bring in our calculator view so that we can modify its properties. So if we just run this right now and don't set like these warnings that Amanda noticed earlier, nothing is going to change in our label. So we have to bring in our view so that we can set those properties. So it's just going to be calculator autofill for me, please. No? Okay, that's fine. Dot result label equals that. Oh, all right, cool. Another learning lesson. What's wrong? What's that? It is a string, but oh, are you talking about the result label or the calculator? Yep, exactly. So that is referencing the UI label component itself. You want to make sure that whenever you're wanting to look at the text of a UI label, you always put in text. to on that. Cool. Do you guys think it'll work? Probably, maybe, probably not. Looks like it doesn't. Why not? So it looks like we're hitting things in the view, but let's see if we're hitting things in our controller. So if everything's hooked up properly, we expect these to be hit. So let's run through. Numeral press wasn't triggered. So something's wrong. I guess I shouldn't expect you guys to know this. So whenever you bring in a delegate, you have to make sure to set yourself to that delegate. So in the view did load, we have that calculator view. And we want to set its delegate method to self. So basically, this sets up your controller to use all the delegate methods that you've just implemented. So now if we run, it should be hooked up.
So I guarantee you will forget that.
Every single time.
Bang your head against the wall.
Yeah. Yep. There we go. Plus, we're gonna hit our breakpoints and kill this guy. Run through. Operator value is not defined. So, let's see. Alright, so just missing it here in the calculator view. Model dots value equal to button value. We did it. It's all in a model view controller now. So, if you guys remember what we had before, it was a lot different than this, right? So, it's a lot cleaner too, so everything has a role now. So, you know exactly where all of your view components are. They're all in the view, calculator view, and you know where all the logic lives now too. It's all in our calculator model. So, it's sort of, when you come into this project now, everything's a little bit better organized than if you had everything in the view controller all in one. Delete some of these comments. I know it's a little tricky at first, especially delegation. It's not an easy concept, and don't feel bad if you don't understand it right away, because we'll be going over it a lot over the course of this semester. So, did you guys have any initial questions? I know that was a lot of information, and there was a lot of struggling on my part too. But yeah, absolutely. Sure. Yeah, absolutely. This was a live code demo, so those always go smooth. Right? But yeah, do you guys have any initial questions at all over this? Yep, absolutely. Everything that we go over today will be made available on the LaunchCode website, so make sure to stay tuned. All All right. Well, if you guys don't have any further questions, we'll create an application from the ground up using MVC. So I know this was a little painful, but it was good to go through like what you might do in the beginning because they do give you a view controller when you first start a project, and it's really easy to just dump everything in that view controller. But if you go through this route first, it's a lot easier. So make sure you use MVC or any kind of design pattern when you first start off, and you won't have to go through the painstaking process of refactoring your code into these different classes. All right, cool. So, are you guys familiar with making a completely new project? Single view app. All right, we'll call this puppy flash cards. And desktop. What I usually like to do in the beginning, especially because these files really aren't terribly relevant for things, is I usually group these into supporting files. Group from selection. Files. And this just keeps it a little bit more organized, but we did move a file, and if you actually run it right now, it's going to blow up. Have you guys had this error before? Cannot read data from this.
I think they did, but it wasn't addressed directly.
Oh, perfect. So I guess you guys have seen this issue before. Did you know how to resolve it? Yep. You go to your main project structure, you go to build settings, and right here is our culprit. So we moved the info plist file. It doesn't update this directory path automatically. So all you have to do is specify where it lives. So we moved it to supporting files. If we change it and run, it should work fine now. All right, so everything's happy. Cool. So, I guess me personally, I usually like starting off with a model class first, so we'll go ahead and do that. So, um, does everyone know the premise of this app? So, have you ever used like a flashcard app, like online or anything? So you can go through different tiles, and you can look at there's a front tile and a back tile, and you can click on it to reverse it to see what it actually is. So we're going to do that with puppy pictures and names. So remembering names to puppies. We'll have the name of the puppy on the front card, and then we'll have the picture on the back. So we'll go ahead and make our model class. Cool. So this only imports foundation, so you have to make sure to put your class name on it. Puppy card model. And we're going to go ahead and knit this right away. And instead of having you guys sit painfully through me writing out all these things, I'm going to copy paste, but I'll explain it. I'll just have this file structure. So we'll have a puppy card list, and we do need to initialize it. So we'll do let puppy card list. Actually, before we do that, we do have to define these structures. So structs puppy card, and this will just have puppy name, string, also image, which is also string. Get that right. make sure you define them as either lets or vars. So whenever you make a struct, typically you want them to be lets because you're not going to be changing them. But if you do have to change them, say you were making a struct for something that you were trying to modify, say you had to modify the puppy name, you would change that to a var instead. But under this circumstance right now, we'll keep them as lets because these names won't change. And then when we define our puppy card lists, it'll just be an array of puppy card. There you go. So now that we have our structure, what do you guys think are some of the operations that we'll have in this model class? So if you remember on the calculator, it was just the performing actions for like operators, plus, minus, and equals, and things like that. Do you guys have any ideas of what this might be? Certain actions. Yep, flipping the card. That's one of them. Yep, going to the next card, and along with that, going to the previous card. So we'll go ahead and make those functions real quick. Card. Next card. This card. Alright, so something that we'll need is, let's put current display on this. So we'll have two sides to this card, and we'll also need to keep track of an index to go through this. So kind of like what we said before, how your model sort of maintains all of the data, we need a way to iterate through that data too, because we'll be going to next and previous, and also flipping the card. So we'll create a current index, which will be an int. We'll instantiate it as 0. Also, current display will allow us to basically pick which puppy card is currently being displayed. I'll do a string. Oh. Actually, before I do that, do you know what's wrong? Yep, exactly. So kind of like what was wrong before, it's the opposite. So you have to remember that you have to specify what types are being passed in whenever you define this card. So whenever next card is called, what is something that we'll need to do? Yep, increment the index. So self.current index plus equals 1. And we'll probably have to check, right? So if next card goes beyond the scope of our array, it'll probably it'll probably throw an error because array index is out of bounds. So we'll probably check if self.current index is less than or equal to puppy card list dot count. This card. And we'll just set this to back to what we had it before, which is 0. That should, yeah. So we'll go ahead and also return this current index. Greater than or equal. My bad. Good job. We're mobbing this out together. All right. So same thing here. We have to specify a return type. Alright, so for previous card, it's going to be a similar concept, right? So we're going to have to decrement this counter. That current index minus equals 1. Um, if the self.current index is less than or equal to 0, or less than 0, yeah. We'll set the current index to self.puppycardlist.count. Okay, self.puppycardlist counts index. Cool. Alright, so flipping the card. Specify. Perfect. Alright, so for flipping the card, what do you guys think we need to do? We have this puppy card list, and the first thing that you'll see is the puppy name. And then when you click on the card itself, it'll flip over and show the image, right? So we'll probably have to set current display to the image or the puppy name. So we have to flip between those two. Display is equal to self.puppy card list current index we'll switch it to the image. So oops. Open this card. Current index image. Oh, alright. Just messing up parentheses here. Alright. Cool. Unexpected number. Perfect. So do you guys have any questions over what we just did? So flipping the card, we have going to next card, and also we have going to previous card. And that'll all be controlled within our model. So similarly, we'll create our view class. So we'll go and do that now. And we can use the Coco Touch class, and we'll do puppy card view. Perfect. So, do you guys know what the first step is when you create a completely new view? Storyboard. Alright, so we actually don't have anything yet, but we'll go ahead and do that now. So we'll just create a really big button, and this will act as our image. So we'll just do this. And does anyone know how to... So, oh, I got it right on the storyboard, but do you know how to modify those dimensions on the right thing? Ruler? And then here. So if you get annoyed by trying to move things in the storyboard, you can always go to this ruler, and you can change the width and height here to what you want. We'll also go ahead and make this have a background so we can easily see it. I'll go ahead and change the text color to white. There. We could probably make this font a little bit bigger too. 36. 42. Cool. All right, so we have our button. Now we're going to need two more buttons, right? So actually go ahead and use a ruler here and change this to 80, 80, and then change this. We'll just make this row. A little less there. All right. Do you guys have any questions over this process at all? It's pretty straightforward, right? Just dragging buttons over to the storyboard and formatting. Have you guys had any issues with layout of things on the page at all? Maybe constraints? Cool. So we have all of our buttons. Well, I guess we don't have buttons. So we have all of our buttons. What is the next step in this process? Hmm? Yep, exactly. But even before that, we have to hook something else up. Maybe the view. Maybe specifying the class of the view to what we just made. So if we were to pull up, I guess if you ever run into this issue where you have your view and you're trying to drag your outlets over, small monitor. All right. So if you ever run into the issue where, oh no, object exit. So this isn't allowing us to connect. Interesting. I think this is actually going to crash. So we actually didn't hook up the view, so I'm kind of surprised that it actually allows you to drag over an outlet. But maybe it's smart enough to know exactly. Yeah. Yeah. I'm actually curious to see if this actually works. We'll do some experimenting today. So, see, we'll drag this button over as an action. UI button, test. We'll go ahead and put a print on here. Alright, so we do have this button, but you'll notice nothing's working. So this is actually even worse because it allowed you to hook up your outlet and it's just strange behavior now. And you might be sitting here and wondering why nothing's working. Just remember that whenever you hook up, create your view to hook it up to the actual class that it has to be a part of. So as part of the puppy card view, let's get rid of this, get rid of these two, then control drag now, and if we have an action, Um, test type print work. Then run this. All right, cool. So it works now. Just make sure to set up your view, and if you ever find yourself not being able to detect a button being clicked, that might be one of the things that is wrong. All right, so let me go back here. I'm just going to reset to suggest and put the strengths, and then we'll go back to our view. We'll hook all these things up. Action, previous, button, pressed. Next, button, pressed. Oops. All right. You might find yourself doing this a lot too. So I wanted I wanted an action for all of these, and you delete them. Um, the thing is, whenever you delete them, they won't be removed from your referencing outlet, so that could cause issues too. So let's do that again, and we actually want actions. And make sure whenever you're making this action to select the UI button as a type, otherwise you won't be able to pull any of the information from that button, because it would be a type any. Button pressed. This button pressed. Action. Alright. Alright, perfect. So now, coming off of the previous example that we just did, what is our step? So we've made our model, we've made our view, we still have our controller, right? What is the next step after this? Looks like our puppy card view is a little lonely, right? We might need to make some protocol methods so that our controller can actually interact with it. So protocol card view delegate. It's a class. You guys know what should go in this protocol? Mm-hmm. So these three, right? Specifically, puppy card pressed. Cool. So now we do have to make our bar puppy card view delegate. Actually, you can just call it delegate because it's inside the puppy card view. Yep. So it would inherit from your delegate that you just made. So initializers, perfect. And then in each of these button calls, you would just call delegate dot puppy card pressed. Actually, I'm gonna lowercase this for sanity. Yes. request. All right, cool. So in our view controller, we'll just instantiate that view, right? So that'll be card view equals UI view. Set that to here. We'll just return view as. Are you guys familiar with this syntax? Returning view as something else. So we're gonna return this as a card view. So what this basically does is that it tries to cast whatever's on the left side to the right side. So it's taking this generic UI view and casting it as this puppy card view that we just created. Now, it's still an optional, so if you remove this and just did as, it would complain at you because casting is kind of like unwrapping an optional way because it's trying to cast this view to this puppy card view, and if it fails, it'll bomb out on you. So you do have to put. I force unwrap it here because I know that the view is going to be there. But if there's an instance where there's a potential of that view not being there, make sure you use the question mark because it'll return a nil, and then you can actually check for that. And I think I remember you mentioned earlier about guard statements, so you can actually guard against a nil card view or UI view. Perfect. What else do we have to bring in? Starts with a mo, ends with a dull. Puppy card model. Puppy card model. So the other thing too is there's two ways of instantiating this. You could set it right here outside of the constructor or outside of the view div load, and you could just do puppy card model. And another way of doing this is, say you just wanted to do it in the view div load. You remove this, and in the view div load, it would be like that. So one of the reasons you might want to do this is there could potentially be things that you need to instantiate your model with, and you could do that in the view div load and then pass those parameters in, versus you wouldn't be able to do that here. Oops. Invalid view declaration. So let's just complain about it. Does that make sense? All right. Get rid of this. And most important step here is we have to bring in our pictures. So I'll actually just pull them from what I was working on earlier. Yeah. Sites. Bring all these guys over, and it's actually decently easy to bring them in. You just drag and drop over to your assets, and it'll make them for you. So now you have all of your puppy pictures, and we can reference those. So if you'll notice before in our model, these image names directly correlate with those images that you bring in. So, all right. Now that we brought the view in, you guys remember there was a protocol. So do you guys remember what we have to do for that? Maybe make an extension or inherit something. Maybe make an extension on view controller. That is our puppy card view delegate. So this is going to complain to us again about having to implement those protocol methods. So if we go back to our card view, we have these three functions that we'll have to implement in anything that inherits from this delegate method. So easy way of doing that is just hitting this, and hitting fix, and it'll fill those stubs in for you. So this is where we're gonna need to flip the card, and we'll actually get the label from the button. So remember how to do that real quick. All right. So this basically goes to current display. Oops. Are you guys familiar with this syntax right here? The double question mark. What's that? No, it's specific. I think it's specific to Swift, but this will basically evaluate your text, and if this is where optionals come into play again. So if it's nil, it'll just evaluate this to the double quotes, versus if there was something in the text, it would just take that value. So think of it as more of like a checking case. So if you use double question mark, it'll evaluate that first value, and if it's a value, it'll use that value. Otherwise, it'll use the double quotations or whatever's on the right side that you specify. Current display. Current display. You guys have any questions so far? I know this is a little mundane, but it's important and it'll help you in the next projects that you'll be working on. So we have these delegate methods. Oh, oops. All right, so does anyone have an idea of what we might want in the delegate methods for next button pressed and previous button pressed? So remember that we're in our view controller right now, and we're wanting to talk back to our model, right? So on the view, we press the previous button, and we want the model to understand that we did that. So we might want to call copy card model. And if you remember last time, we did have next card and previous card functions, so we can use those now. Alright, cool. Stirring. Oh, perfect. Alright, so should pull it up. It looks like I did. What did I miss? So it looks like we're pressing this button, but nothing's happening in the controller. What's wrong? Why is this not working? There's one important step that you're gonna forget every single time you use delegates.
Remember what I told you? Bang your mind on this.
Yeah. Yep, it's something to do with self. You have to remember to set your card view delegate to yourself when you're. It's not auto completing for me. Makes me nervous.
I don't like it when it doesn't.
Oh. Haha, another learning lesson. What's wrong here? So value of type UI view has no member delegate. It has something to do with this line right here.
Value of type UI view card, no member. Card.
Yep. So if we fill that in, it should recognize it, and if we rerun this, it should be good to go. So I know we're running a little bit out of time, so I'm going to fill in the logic for you guys, and if you guys have questions over those, we'll go over them. So looks like that's all hooked up. Um, so do you guys have any questions over like model, view, controller, and how everything integrates together? I know it's a lot of information, especially throwing delegates on you guys too, and also models and views and controllers and everything. But does this design pattern sort of make sense, and what are like the advantages of those things? Good. Cool. All right. So go ahead and put this, and I'll post all of this online too, so you guys have a reference to it. This is just logic to make like previous buttons work and all those things.
That makes sense now and you go home and suddenly forget everything. Yeah.
Mm-hmm.
I have no idea what that's like. Feel free to contact us and ask questions.
Yeah, we're on Slack pretty much all the time. So if you guys have any questions, even midnight, like I remember answering questions at 2 a.m. one time. So feel free to post your questions.
I'm not going to be that person.
My computer is.
It's a little tired.
It's a little tired, yeah. All right. Alex. And if we click on that, puppy. Oh, go next. Bandit. Next. Toby. This image is a little bigger. That's my dog actually. But looks like my dog crashed that. There we go. Oh, Lassie. That's a trash panda. But yeah, this is pretty much um, what model view controllers can accomplish. So yeah, that's pretty much the lesson. And I know I said I wanted to leave some time, so we have 10 minutes to go over any homework questions you had, or if you guys have any questions over what we did in class today.